Hello, Assalamu alaikum sir. My name is Sadi Muhammad Faisal and my code number is 19101120 and we are the group 14. So to build our second project, we have initialized the environment of our first project and we have changed it a bit. We have changed the background, we have changed the wall design, and we have updated our robot from 4-wheeler robot to 2-wheeler robot. That's it. So to build the track in this project, we need to first of all go to the Tinkercad website. Then we have to click on the create new design. After that, we will select the Scrabble option and click on the work plane, and then we will design our desired diagram or track for the robot to run on. Then we will give a solid color to the track, which is black. Then we will scale our track. Then we will export it to .obj file, and after downloading the file, we will go to the download option and extract the file. Then we will go back towards our obj file. Then we will import, then by clicking the 3D model we will import our track. Here we can see that our track. Now by resizing it and with proper translation we will place the file on our environment so that we can place the robot on it. Now we will place the robot over the track. Thank you. That's all from me. The rest of the parts will be described by my teammates.
Hello, I'm Mohammad Arban Rahman. My ID is 19101106. Here I'm going to talk about our sensor part. So we took the robot from our previous project, made it a two-wheeler robot, and removed all the unnecessary sensors such as the camera sensor and the GPS sensor. Now we are left with the two distance sensor, left and the right one. So first of all, we need to change the axis of this sensor where the z-axis will face forward. In order to do that, we need to rotate the y-axis accordingly so that the z-axis is facing forward and the x-axis is facing downwards. We need to do the same for both of the sensors. Now I'm going to change the direction of the z-axis of the left distance sensor here by firmly rotating the y-axis. Now when we're done with the axis rotations, we need to change the sensor type for both of the sensors. In order to do that, we need to go to the sensor section and find out the type section where we can see it's given generic, and we have to switch it to infrared sensor. We have to do the same for both of the sensor here. And now that we are done with changing both of the sensor type from generic to infrared, for this particular project we'll be needing another sensor in the middle. In order to do that, we need to copy one of the sensor and paste it to the children section of the robot. After that, we need to go inside the new pasted section and find the renaming section where we can rename it to center. And now that I'm done renaming the sensor, all I have to do is place the sensor to the middle of the robot. Here we have all three of the sensors where their z-axis is facing forward. That's all from me. Thank you.
Assalamu alaikum. This is Nur Fatiha Tahiyat, and now I am going to explain the controller coding. So first of all, we have imported the robot from controller and made a robot object. Then we have set our time step value to 32 and base speed value to 5, which basically means that after every 32 seconds, 3 of our IR sensor values will be reset. Then as we have two wheels, we have kept left motor and right motor and initialized them with the value received from the get device function, and we have passed the wheel names to get the motor values. After that, we have set the position of the motors to infinity and set the velocity to 0. Then we can see we have 3 IR sensors. We have initialized them with the values received from the get device function, passing the name as earlier, and then we have enabled our sensors with the time step. Then we have our KP, KD and KI values. We have initialized the KP value as 0.05, basically means the time speed divided by 100. We have a list which consists of 3 values. The left one corresponds to the left IR value, the middle one to the middle IR value, and the right one to the right IR value. Then we can see a PID function receives a value error, and then it uses the global values. This last error, integral, differential, proportional, and KPKI KD. It updates the prop, INTG and diff variables according to the value it received as parameter. Then it calculates the balance value with the help of this equation, and then this function returns the balance to the driver code. Then we have a while loop in here, which basically runs until the robot.step value is positive. In each iteration, it updates the 3 IR values and the wheel speeds. Then it considers some conditions. So first of all, if we have our left IR value less than 1000 and the right IR value less than 1000, but the mid IR value greater than 1000. In this case, we will pass the sensor val 1, which corresponded to the mid IR value, and we will pass it to the PID function as I explained earlier, and from the PID method it will receive the value which will be the balance, and then it will add the balance value with both base speed. It will also set the motor velocities according to the wheel speeds. Here we have used addition because both of the left IR value and right IR value was less than 1000. Then we have another condition where left IR value is less than 1000, mid IR value and the right IR value are greater than 1000. In this case, we will consider sensor val 2, which corresponded to the right IR value, and we will similarly pass it to the PID method and get a balance. We will update the left speed and right speed. We can see we have subtracted the balance value from the base speed as we had our right IR value greater than 1000. Then if we move ahead in the condition where the IR value is greater than 1000 and the mid IR value greater than 1000 but the right IR value less than 1000, we will set the error value to -1 into sensor val 0. This 0 corresponded to the left IR value, and we have used -1 here for the direction corresponded to the left IR value. Then we have passed our error value to the PID method and updated the other values accordingly. After that, if we have our left IR value greater than 1000, we will also multiply a -1 to the sensor val 0. Similarly, we will update the left speed, right speed, and the velocity. And lastly, if any of the other conditions are not satisfied, it will simply be passed. The loop will start to run again. So that was it from my side. Thank you.
Assalamu alaikum, I'm Tahmin Ahmed from CSE461 section 5 team 14. Fatiha has already shown how the compiler code works, and I will show the iteration of the code and how the robot moves, compile and run. For that we have to go to the wizard and then new robot controller. After that we can go ahead and create our controller. We will be using the language Python in our case, and next and create our controller. We can also see here our controller code has made, so we will go ahead with our existing controller code. So for that, under robot we will go to the controller, we will select our controller code, and from here we will select the controller code from CSE461 Final Project. And here we can also see the name of our project is also CSE461 Final Project.py. And now we are ready. Let's run the code and see what happened. We can see our robot is successfully moving towards the accurate line, and it is not being fluctuated. Our robot is working well. So that's all from myself. Thank you so much.